Good morning, good afternoon, and good evening, everyone. My name is Ani Kazaryan, and I'm really glad to welcome all of you in the second event of the United Nations Office for Outer Space Affairs 2023 event series in the framework of our awareness raising and capacity building related to the implementation of the guidelines for the long-term sustainability of outer space activities, or as we usually refer to this document, the LTS Guidelines. The LTS Guidelines is a voluntary instrument which was adopted in 2019 by the United Nations Committee on the Peaceful Uses of Outer Space, or UN COP+. Through this year's project series of UN-USA, we dedicate one event for each section of the LTS Guidelines, so from A to D, which means 4 events in sum. And as you may know, last month we had our first virtual event on Section A, on the regulatory and policy framework for sustainable space activities. And you can download the recording of the event, the short summary report that we prepared about the event, and many more documents, informations, and case studies, and even our stakeholder report from last year relevant to the implementation of the LTS guidelines. So you can find all these documents and informations open source, downloadable on our project website at spacesustainability.unusa.org. And of course, we wouldn't have been able to carry out all these project activities without the financial support of the United Kingdom, so we are very thankful for them. And now, new month, new section, we are focusing on the implementation of Section B of the LTS guidelines. So all the 10 guidelines out of these 21 LTS guidelines, which reflect from different angles of the safety of space operations, which will be scrutinized and discussed by our esteemed panelists today. And I'm very pleased to introduce you the moderator, Dan Aldridge, who will lead the event and the discussion today. Dan is the Chief Scientist and Director of the Center for Space Standards and Innovation at Comspoke Corporation. And before I would give the floor to Dan, allow me to quickly go through the agenda today, which is very similar to our previous events. So we will hear a 6-minute introductory remark by each panelist sharing their first-hand experiences related to Section B. And after that, Dan will open the floor to a 45-minute conversation, including Q&A. So please type your questions in the chat starting from now. And please also keep your microphone and your video off during the event. And please know that the event is being recorded, and you will be able to access the recording in UNUSA's YouTube channel and, of course, on our project website at spacesustainability.unusa.org. And now I would like to give the floor to Dan, as I'm really pleased and very excited to hear all the remarks and conversations on Section B led by you. So thank you.
Yeah, so thank you, Annie. It's a pleasure to be here and moderate this panel. As Annie said, this is event number 2 of their project, and we're going to be focusing almost exclusively on how the guidelines contained in Section B of the long-term sustainability document, which is the safety of space operations, are being implemented. We'll be engaged with some diverse experts here, including several space policy experts, a space surveillance and tracking director, a large constellation operator, and developer of commercial and international standards and best practices. Just to note, events 3 and 4 will be coming up in mid-June, the 12th of June and 26th of June, respectively, and they'll be looking at later sections of the document. So let's begin by exploring what guidelines are contained in this subsection B. Let me pull up a slide here. And this is just a very terse description of what's in each of the 10 guidelines that are contained in Section B. And if you look through these, you can kind of see that guidelines B.1, B.2, B.3, B.4, and B.6 all have a heavy emphasis on sharing of either space object or space environment or conjunction data. how, encouraging us all to share data with each other. And most of the other 5 guidelines also will have some derived requirement or some derived element or aspect dealing with the sharing of data. So that's kind of a constant theme throughout this section B in my mind. Guideline B2 is improving our positional knowledge of things on orbit, which can be thought of as a prerequisite to B4 and B5. You can't do conjunction assessment either for on orbit or for launch unless you have accurate orbital positions with time. B6 and B7, if we jump down there, these both deal with sharing and generation of space weather indices, proxies, and forecasts. And then B8 deals with the promoting design approaches and operational constructs that increase the trackability of space objects. Guideline B9 is seeking to reduce the risks associated with the uncontrolled reentry of space objects. And finally, Guideline B10 encourages measures for protection and precaution when emitting laser beams into space. So if you take all these collectively, these are, in my mind, in section B, this is the practical implementation within the framework established in section A of the long-term sustainability guidelines, and in the form of safe space operations. In the grand scheme of space governance, guidelines are not directly legally binding. These are guidelines. And so if I turn to this slide here, showing kind of how from a non-mandatory to mandatory basis and a top level down to a detailed level, guidelines kind of fit in this bottom center here because they're only mandatory if people implement them, which is what we're talking about today. And they can be a little bit top level in that they're saying, hey, this needs to happen, but we're not going to tell you directly how to do it. But guidelines do spur other elements of space governance picture into action. For example, commercial operators and SSA providers can use these guidelines to build aspirational best practices over here on the left. And then standards developers can focus on standards that codify the guidelines in normative ways. And then on the right, national regulators can focus on building regulations and requirements that are practical implementations of LTS guidelines. So actually today, you're going to talk to people spanning this whole top row who are taking these guidelines and finding ways to implement them. So now I'd like to introduce you to one of the practical implementations of the LTS guidelines. The Space Safety Coalition is something that I work on, and it is a purpose-formed coalition created to assemble aspirational best operational practices. It's not a legal entity. Endorsement and subsequent participation is free and open to the endorsees who have a direct and material interest in spaceflight safety. So in this particular implementation, the Space Safety Coalition has developed a best practices document that has 2 main parts to it. The first one is a endorsement of existing guidelines, standards, etc., including IDC, UN, ISO, and CCSDS documents. And then it has a further 40 plus specific best practices to further enhance and aspirational go beyond the minimum requirements contained in any of the above. So this document is unique in that it's building upon the already good content in all these international guidelines and best practices. It does span all phases of flight, and although it's not normative, the signatories endorse and agree to promote and strive to implement these best practices. We do have a brand new version of this document out. It was published on the 4th of April. This just lists some of the various elements of it and some of the updates and enhancements we've made over the previous version. This chart just shows you kind of the number of endorsees we've had just since April 2023 and the countries and locations that their headquarters are in. You can see that not quite half of the endorsees are from the US, but we really have a pretty good representation from many, many countries and across the whole gambit of types with operators and manufacturers and analysts and consultants and disposal services and so forth. Now, naturally, you might want to know how these Space Safety Coalition documents map to some of these long-term sustainability guidelines. This lists the guidelines. Here on the left is the section B guidelines I showed earlier. And then the green shows that there is content in this SSC best practices document that relates to and addresses those. Now, there is a much bigger and much more complicated picture if you were to look across not just the SSC document, which is column C here, but ISO and CCSDS and state actors and commercial spacecraft owner-operators, the Space Data Association, and commercial SSA service providers, space situational awareness. And there are elements in all these columns where they are addressing and implementing the guidelines. But now I'd like to get moving and proceed on to some of our distinguished panelists. So first up, I'd like to invite Andrew Ratcliffe, if he's on the line here, to talk perhaps about the concept of UK licensing and operator best practice. Andrew, please introduce yourself as well. I think you're still muted, Andrew. There we go. Thanks.
Thank you very much. Sorry about that. Thanks for that, Dan. So first of all, good morning, good afternoon, and good evening to all those joining this event today. First of all, I'd like to express my thanks to both UNOSA for organising this discussion on this important topic, and then also for Dan for moderating. So as Dan mentioned, my name is Andrew Ratcliffe. I'm the Chief Engineer at the UK Space Agency. Within this role, I lead an engineering team which provides technical assurance to the wide variety of activities that the Space Agency is involved in. As part of this, I also sit on a number of international forums, such as the UN COPIUS Science and Technical Subcommittee and the IADC, which is the Interagency Space Debris Coordination Committee. On both of these, I act as head of the UK delegation. Prior to joining the Space Agency, I worked in industry, developing space technology and designing future science and exploration missions for the European Space Agency. So I hope within this discussion today, I can provide both the regulatory and engineering perspective. To provide some context, and for those who are not aware, the UK Space Agency plays a major role in delivering the UK's national space strategy, and we do this across three elements. So first of all, we catalyse investment by supporting projects that drive investment and generate contracts for the UK space sector. We deliver missions and capabilities that meet public needs and advance our understanding of the universe. And we champion the power of space to inspire the general public. So to achieve the greatest impact in these three areas, we focus most of our resource behind 8 priorities, which extend from discovery in science and exploration to launch. One of these priorities is space safety and sustainability, where we support a variety of projects from technology development to new missions, which we will hope will contribute to the preservation of the space environment for future generations. The UK has also put significant importance on the appropriate regulation and licensing of our commercial space operators, through our National Spaceflight Regulator within the Civil Aviation Authority. Many of the policies, national capabilities and technologies being developed or supported in the UK align with the long-term sustainability guidelines. And over the past few years, the UK, recognising the importance of sharing implementation approaches, has released a series of conference room papers at sessions of the Science and Technical Subcommittee to provide updates on our approach to the voluntary implementation of the guidelines. So relevant to the discussion today, and section B, which focuses on the safety of space operations, implementation examples include the publishing of the UK's Registry of Outer Space Objects on gov.uk, on the gov.uk website, which addresses the need to share information on space objects within B1, and also the establishment of the UK's Monitor Your Satellite service to provide conjunction alerts to the UK operators, which address the need within B4. But I should say that although section B is titled Safety of Space Operations, safety is intimately linked to sustainability. So approaches to ensuring safe space operations are found across 4 sections within the LTS guidelines, from encouraging the consideration of space debris mitigation guidelines within a national within the development of national regulatory frameworks within A2, to the consideration of design for demise techniques within the research in D2. So in summary, the UK is extremely supportive of initiatives such as this to share approaches to the voluntary implementation of the long-term sustainability guidelines. It's only through the sharing of these practices can we converge on good practice, share challenges and identify capacity building efforts. Thank you very much.
Thank you, Andrew. Now I'd like to turn to Pascal Fauscher. And maybe you can introduce yourself and tell us, perhaps with your distinguished roles with EUSST and CNES, how you work to implement LTS Guidelines Section B. Thanks.
Thank you very much, Dan, and good morning, good afternoon, and good evening, everyone. And thank you very much to UNOSA for organizing this important event on Section B of those LTS guidelines. So on my side, I work at CNES headquarters in Paris, at the Directorate of Strategy in Defense and Security. And so I work at strategic and policy level, mainly covering different topics related to space situational awareness, space surveillance and tracking, space traffic management, space debris, space weather, near-Earth objects, etc. So 11 years ago, I started as an expert in the working group on the long-term sustainability. In the expert group B on space debris, space operation and tools to support collaborative space situational awareness. So it has started already, it has started in 2012. And 2 years ago, I was appointed by the French Ministry for Europe and Foreign Affairs as the national point of contact for the working group LTS 2.0. So I bring a support to my Ministry of Foreign Affairs. First, maybe in my remarks, I would like to recall that France has always played a tremendous and active role in the LTS process. And from the beginning, France was even at the origin of the creation of the LTS working group when the French, Gerard Bachet, some of you may know him, made this proposal of creation in 2008 in his capacity of chairman of COPOS at that time. So today we have 21 consensual LTS guidelines and a corresponding preamble, which are a major achievement for the Committee of Peaceful Use of Outer Space. And thank you very much, Dan, for the very good overview of those guidelines in Section B. And maybe my main message first here in those remarks would be that it is our collective interest to timely implement these LTS guidelines in order to increase the long-term sustainability of outer space activities. It is really our collective interest, the collective interest of all nations to encourage the responsible use of space, to minimize space debris, to protect spacecraft from risk of collision, and to preserve the space environment for our future generation. So therefore, those efforts to raise awareness and to build capacity related to the implementation of those 21 guidelines should be our top priority for all of us. And today the focus on space safety, on safety of space operation is very important because those guidelines are very concrete. They are very pragmatic. So if you look at those guidelines B1, B2, B3, and B4 on sharing information on space objects and orbital event, on improving accuracy, on collection of space debris, monitoring information, on performing conjunction assessment. So all those guidelines are related to space surveillance and tracking. And in that domain, CNES, as a French space agency, is a key actor in outer space sustainability and in the implementation of those voluntary guidelines. So we work closely, of course, with our different ministries, of course, the Ministry of Armed Forces in the SSA domain. And we also work with a very rich ecosystem of governmental, of private actors. And all together, CNES, the French Ministry of Armed Forces, and all the rich ecosystem, today they develop all together those capabilities to detect, measure, and catalog the orbital population using different technologies. So they can, those technologies could be passive radio frequency sensors, laser sensors, optical sensors, able to observe LEO to GEO by day or by night. We have radar sensors as well as adaptative optics to observe the orbital population in a resolute manner. So those capabilities are today used on a daily basis, and they are used also in the context of the European Union with our partners. So together, 15 member states of the European Union joined their forces on space surveillance and tracking. And all those member states, France, Germany, Italy, Poland, Portugal, Romania, and Spain, and recently on 11 November 22, exactly 6 months ago, 8 new member states joined EUSST, this partnership on space surveillance and tracking in the European Union. So Austria, the Czech Republic, Denmark, Finland, Greece, Latvia, the Netherlands, and Sweden. So all together, those member states put in common their national sensors and invest at national level in space surveillance capabilities to provide operational services in collision avoidance, analysis, re-entry, and fragmentation. But maybe I would like also to focus at national level on guideline B6 and B7. Those guidelines on space weather, on sharing operational space weather data and forecast, and develop also space weather modeling and tools. Those guidelines are very important. And on my side in France, I have the privilege to chair a French coordination group on space weather, with the participation of more than 40 experts from a number of research institutes, government agencies, Ministry for the Armed Forces as well, Ministry of Research, and a number of companies. So they all work together to coordinate actions at national, European, and international levels. And we provide all together an assessment of impact on 4 domains: on defense, space, civil aviation, and also technological ground infrastructure. And the objective is to promote sharing of information on space weather, like post-event analysis. So this is very important that in France we have an active French scientific community. And on that topic, I would like maybe to promote one important event that will take place in France, in Toulouse, the European Space Weather Week. And it's going to happen during the week of the 20 November. So please come in France. We will welcome you for this European Space Weather Week in Toulouse. I would like also maybe to focus on, of course, France is very much involved at European level in the context of the ESA Space Safety Program. And at an international level, I think there's an important topic, which is to better define and characterize extreme space weather events and their probability of occurrence. and assess their impacts on technological systems with a focus on spacecraft and aircraft. So this work should be done at international level. And this is a topic which is a priority for us in France. At international level, we also have a very important cooperation in the context of the International Civil Aviation Organization, where France, together with Australia, Canada, and Japan, provide space weather services to the international aviation. And so we are very happy to contribute to this endeavor. In addition, and maybe I will finish with this last topic, if we project ourselves in the future regarding space weather, probably we will have more and more space weather mission conducted by the industry as a service. And this is something very important to contribute to the long-term sustainability of outer space activities. I will stop there.
Okay. Thank you, Pascal. Very comprehensive answer, but a lot of important topics you raised. So appreciate that very much. Next, I'd like to turn to Phi Chusri, who I hope can tell us a bit about the Thai National Space Master Plan and their policies and space laws. Phi?
Thank you. Okay, can you hear me? Okay.
Yes, just fine.
Thank you. Thank you. So today I would like to share some information regarding Thailand. Firstly, I would like to share the information about B1. So at the present, GISTA, which is Geoinformatics and Space Technology Development Agency, which is the space agency of Thailand, has promoted the registering of the space object launched into outer space by cabinet resolution. According to the resolution, GISTA is a national focal point to register the space object within Thailand. Moreover, we also send that information through our delegates in Vienna in order to pass the information to you in USA. Therefore, we try our best in order to do this. And in the future, we are still in the process of drafting the national space law. Therefore, GISTA will be designated to engage in exchange of information about on-orbit spacecraft operation, conjunction assessments, and monitoring of objects and events outer space, as well as the exchange of relevant information on space objects and information related to actual or potential situations in near Earth space that may affect the safety of outer space operation. So that's the regulatory process that we are doing right now. Moreover, I would like to share some information regarding the policy about B5. So at the present, even though Thailand is not the signatory state to the Convention on the International Liability for Damage Caused by Space Objects and the Convention on the Registration of Objects Launched into Outer Space, as well as there is no launching site and concrete procedure for pre-launch conjunction assessment in Thailand. Right now, most of the satellite had been launched by the foreign launch service provider under the turnkey contract. But however, in the future, we think that if national space law is enacted, GISTA will be designated to authorize and supervision as well as permit launching under the turnkey contract by giving the authority. And GISTA will be engaged in exchange of information on pre-launch, conjunction assessment, and exchange of the analytical assessment of the risk collision of space objects. Moreover, under B9, to take measures to address risk associated with the uncontrolled re-entry of space objects. At the present, according to the Thai cabinet, as I mentioned to you guys earlier about the registration of the Thai space object, if the space objects are no longer in orbit or change in the position from the previously transmitted information, the satellite operator is obliged to notify GISTA to further inform the Ministry of Foreign Affairs in Thailand and pass that message to UN-USA. In the future, if the national space law of Thailand is enacted, GISTA will be the designated to have the procedure for furnishing information on the forecast uncontrolled re-entry of potential hazardous space objects that are under Thai jurisdiction and on control. Moreover, the National Space Policy of Thailand established the subcommittee on the SSA and STM policy, monitoring and management responsible for the re-entering of objects events that can be harmful. The members of the subcommittee nominated from relevant agencies within Thailand, such as the Civil Aviation Authority of Thailand, the Royal Thai Air Force. Their process of work to respond re-entry space object includes information assessment and risk analysis. Moreover, there also be the notification to the stakeholder in the country. So this is all I would like to share for today regarding the space policy and the regulatory level of Thailand. And now I would like to share about some operator work that we have been worked in Thailand recently. Under guideline B4, perform conjunction assessment during all orbital phases of control flight. GISTA has developed space traffic management system, we call it CIRCON, for our satellite. The system can provide services for operating the satellites in 4 areas. Number 1 is screening the risky objects. Number 2, the prediction analysis. Number 3, the collision avoidance strategy. And number 4 is visualization tool. So this is the software that we developed by ourselves. And for the future plan, we are interested to add more function to the software, such as the frequency interference, monitoring of the re-entry of space object and others. For B6 and B7, we are also undertaking space weather operation and research in 2 parts. The first part is the observation infrastructure, and the second one is the space weather forecast system. I would like to inform you guys that at the beginning of this year, during the STSC Corpus in February, GISA also participated in International Space Weather Initiative meeting. We share our activities pertinent to space weather research and operation in the country. We look forward to support the work of the initiative and other space weather database. So that's all I would like to share for now. Thank you.
Thank you very much, Fee. Appreciated those comments. Now I'd like to turn to Emmanuel David, who can tell us a bit, first introduce yourself and then tell us about the Space Sustainability Rating and its relationship to LTS Section B.
Thank you very much for the introduction, and thank you very much for the invitation. I'm Emmanuel David. I'm Executive Director at eSpace at the EPFL Space Center, the Swiss Institute of Technology in Lausanne, Switzerland. And I'm also the Vice President of the Space Sustainability Rating Association. Let me first walk you through a bit what is the SSR. I'm really glad that it's the second time I'm able to present about the Space Sustainability Rating in a UN context. We were presenting in February 2022. What is the Space Sustainability Rating? And then I will explain to you how the SSR is answering to the long-term sustainability guideline with the focus on the Section B on the safety of space operations. So the Space Sustainability Rating came into an initiative, was first conceptualized in 2016 within the World Economic Forum Global Future Council on Space Technologies as a tool to assess and quantify sustainable design and operational decisions taken by operators. So the main idea here was to create a voluntary mechanism to avoid imposing anything on the global community. ESA Space Debris Office and the Massachusetts Institute of Technology, MIT, supported with Bryce-Tech and the University of Texas at Austin, led the development of the SSR together with the forum. And in 2021, eSpace, so my entity, was selected to host and operate and issue the SSR, which went live in June 2022 and issued the first official rating. And in late 2022, we also created an association of Swiss law in order to perform the operation of the rating. So what is the Space Sustainability Rating? The design considers key decisions the space operator can make during the design, the operation, and the end of life of a space mission. This aims at ensuring that the mission implements designs and operation that goes above and beyond current best practices, enabling the operator to demonstrate its own pursuit towards responsible and sustainable operation in space. There are different modules in which the SSR consists of, highlighting key related decisions by space operator throughout all phases of the missions. And these missions include the mission index to estimate the mission marginal contribution to the overall orbital risk, or what we could also call the mission footprint to the orbital environment. The collision avoidance capabilities, COLA module, in which we capture how the operator, the knowledge on the orbital state of the satellite, the availability also to coordinate, the capability to coordinate, and also the maneuver capabilities of operators. There is also a data sharing module, which captures the ability and willingness of the operator to share data on the mission, with the collision avoidance coordination information, satellite metrics information, and characterization information. A module on the mission's detectability, identification, and tracking. The operators also a module on the compliance with applicable standards and regulations, and also the commitment to use or demonstrate the use on on-orbit servicing and external services. The different modules take into consideration the short and long-term effects on others operators and also on the environment globally. And then a rated mission receives a tier score that will determine the rating level between bronze, silver, gold, and platinum. As you can see, the space usability rating is a soft tool that can grow also along the LTS guidelines with this modular structure, and is also designed in a way to provide flexibility and room for evolution and improvement with the technology and the policy evolution in a fast manner. So how does the SSR answer to the long-term sustainability guidelines? First, just as an operator, by participating to the SSR exercise, is also a justification to the compliance of the B1 guidelines to provide information and share information on your objects. Also, the second aspect is largely captured also in the module on standard and regulations, where one of the standards is the long-term sustainability guidelines, where we also perform selections, tailoring of the guidelines applicable to operators, which are in B12, B13, B21, B23, B41, B43, B72B, B77C, B72D, B75B, and B9. I can also share information of the data after. And a third aspect, which is also largely captured within the SSR, are also within the DIT module and the COLA module, so the detection, identification, and tracking module, and the collision avoidance module, which captures most of the guidelines which are described in B1, B2, B4, and B8. The space sustainability rating also addresses other chapters of the long-term sustainability guidelines, which are not the focus today, and more details are also present in a paper published earlier this year along with Dr. Ratnasabha Bhatti from the MIT in the Kluver's Law Journal, and are also accessible on our website, Space Sustainability Rating. This is the rating is a tool that can be used by operators, but also how can states and international organizations use the SSR for the implementation of the long-term sustainability guidelines. Through findings in the literature and along with discussion brought forward by SSR stakeholders, we showed that the SSR could also be used to reward actors in order to provide financial and economic incentives, support for current and potential regulations, a support for procurement processes, enhance also public perception, and communicate on environmental, social, and governance topics. And this incentive are the ones that can also be put in place by national and agency actors with their role of regulators of the space industry, licensing entity, procurement bodies of space-based infrastructure. And the space sustainability rating can act as a neutral third party to assess the level of sustainability based on the criteria, the framework and methodology of the space missions. So to conclude, the SSR provides an innovative way of addressing the orbital challenges by encouraging responsible behavior in space throughout increasing the transparency of the organizations. Thank you very much for the time.
Okay, yeah, thank you very much. I noticed part of your discussion addressed one of the last questions in the Teams chat. I'll probably ask you to expand upon that a little bit more in a bit, but thank you very much. And finally, we'd like to turn to Amber Charlesworth from Amazon. So please proceed, Amber. Introduce yourself and tell us about what you're up to at Amazon with respect to Section B.
Great, thanks, Dan. And it's a rough act to follow there, but I'll do my best. Also, thank you to you and USA for putting this on and inviting me as part of the panel, and the United Kingdom for continuing to fund such an important effort. As representing a little bit of industry here, I'll just start my remarks by saying that I applaud the efforts of the Committee on Peaceful Uses of Outer Space for finding a structure and a format process, if you will, to include industry on the development of the first 21 LTS guidelines, and continuing to include industry in discussions on the implementation of the guidelines, as well as the future work that needs to be done. And because I'm from the United States, I'll also thank the U.S. Department of State, Dick Beneke, Ryan Guglietta, Valdivia Manis Keller, Josh Woolney for continuing to really engage U.S. industry in efforts to implement the LTS guidelines and efforts moving forward to find consensus-based best practices for the responsible use of space. I'll start next by just giving a little bit of flavor of what Amazon Kuiper does. Again, I lead space policy for Amazon Kuiper, so I'm here to share kind of our mission at Amazon Kuiper, as well as delve into a couple of the guidelines so that I don't go beyond my initial time allotted, but happy to kind of delve in deeper as we continue with the discussion. Amazon is committed to building a sustainable business for our customers, communities, and the world, and this focus extends to Project Kuiper. Project Kuiper, Amazon's low Earth orbit satellite broadband initiative, will provide fast, affordable connectivity to tens of millions of customers in unserved and underserved communities around the world. Our network will serve individual households as well as schools, hospitals, business, government agencies, and other organizations operating in rural and hard-to-reach places without reliable internet. To deliver on this mission, we need to help protect the different environments in which we are operating, on Earth and in space. The Project Kuiper team has prioritized space safety and sustainability from day one, and these principles have influenced every aspect of our satellite network, from satellite design and operational plan to the architecture of the constellation itself. We'll start with guideline B1 and talk to you a little bit about our operational plans. Data and information sharing between satellite operators is a critical part of minimizing the risk of collision and harmful generation of orbital debris. We will precisely position the satellites in our Kuiper constellation and operate them with synchronized clockwork-like movements. We will also share information with our operators, and because our satellites follow predictable trajectories, other spaceflight operators will be able to set and adjust flight paths accordingly. Specifically, Amazon will share ephemeris data and other appropriate operational information with spaceflight operators via portals such as SpaceTrack, which tracks satellites and space probes orbiting Earth. We will also coordinate with the Trajectory Optimization and Planning Office at NASA's Johnson Space Center, which will help eliminate any potential flight hazards to human spaceflight or the International Space Station. Project Kuiper was designed to operate alongside existing satellite systems, and we're consistently examining and refining our understanding of the orbital environment to advance orbital debris protection, reduce interference risks, and promote coexistence with other operators. I'm going to jump to B2, information accuracy of orbital data on space objects, and enhance the practice and utility of sharing orbital information on space objects. I just want to take this moment to say that Amazon supports the development of common internationally recognized standards to enable collaboration and information exchange through a collaborative multi-stakeholder effort involving industry and government. And then B4, perform conjunction assessment during all orbital phases of controlled flight. Amazon will conduct active collision avoidance throughout the mission, from early operations after dispensing to post-mission reentry, and use available sources of space situational awareness data to assess conjunction warnings. Amazon will typically begin planning and screening for a risk mitigation maneuver when the risk of collision with another trackable object in space exceeds 1 in 100,000. And I'll finish up with B8 and talk a little bit about our satellite design so that we can turn to the broader discussion. When designing the Kuiper system, one of the most important decisions we made was to include active propulsion systems on every satellite in the constellation. This gives us the ability to control each satellite throughout every phase of its mission. Instead of relying solely on gravitational forces, we can actively maneuver satellites to help maintain distance from other spacecraft and avoid existing debris in low Earth orbit. Our propulsion system includes 2 key components: a Hall effect thruster that propels the satellite, and a propulsion tank that holds enough propellant for the mission. We've conducted extensive testing both internally and with external partners, including NASA, to test the safety and reliability of our propulsion tanks, and we will use our upcoming prototype mission to further study and improve the system. The testing included firing projectiles to simulate the impact of micrometeorites and small space debris and minimize debris creation of this type of small debris impact occurred on orbit. I was going to talk a little bit about our constellation design, and then I'll stop here. In addition to these individual satellite design choices, we also prioritize space safety when architecturing our overall constellation. The Kuiper system will operate at low altitudes between 590 and 630 kilometers above Earth, which allows for quick and reliable deorbit of satellites at the end of their mission, and each satellite will operate within 9 kilometers of its assigned altitude. Helping reduce potential overlap with other satellites in orbit, our onboard propulsion systems are designed to actively deorbit satellites within a year of their mission ending, and these low altitudes ensure that even in the event of propulsion system failure, non-operational spacecraft will decay in a timely manner. Thanks, Dan. Back over to you.
Yeah, thank you very much. All good stuff. I see that we're pretty much right on time here, so I'd like to now open this up to Q&A portion of our panel. I'd like to maybe start with Pascal. There are some countries, this is from our question in the chat, there are some countries which are still not treaty signatories or are new space actors, and they aren't yet active in implementing the space treaty obligations or the LTS guidelines. How would you foresee we could help motivate that to be done, implementation in national space laws and jurisdiction and control?
Thank you, Dan, for the questions. So the question would be, how
do we better motivate either people that haven't signed yet the treaties, there are some, or encourage those as new space actors that aren't yet active in implementing space treaty obligations and LTS guidelines? How do we better motivate that to occur?
Yeah, I'm not very familiar with all the outer space treaties obligations, so maybe I'm not the right one to answer that question.
Okay, how about we just stick to LTS guidelines B then? That'll make it cleaner. How do we motivate new space actors and also countries to implement those guidelines B?
So those guidelines are very important. Those guidelines have been negotiated by member states in COCOS. But for instance, right now in orbit, most of the satellites in orbit are commercials. So it means that we need to incentivize all the private sector to implement those guidelines. And I think all of them are telling us that they would like to have responsible behavior in space. They would like to preserve the space environment. They would like to have safe space operations. And they will play a tremendous role in this domain. For instance, when I count the number of satellites which are right now protected from risk of collision in the European Union, in the USST, which is the partnership I mentioned earlier, of 15 member states, on a total of 393 satellites, right, from 52 owners operators. I can count that we have 289 commercial spacecraft registered to the Collision Avoidance Service. 70 are from governments or international organizations, 13 from universities, and 21 are militaries. But most of those satellites in orbit are commercial. And I think the most important guideline in section B probably is guideline B4 on performing conjunction assessment during all orbital phases of control flight. And if you read carefully this guideline, you see that on paragraph 1, it's written that conjunction assessment should be performed for all spacecraft. And in paragraph 3, spacecraft operators, including commercial spacecraft operators that are unable to perform conjunction assessment, should seek support as necessary in accordance with the relevant applicable regulations from appropriate around-the-clock conjunction assessment entities. So this is very important to implement this guideline to avoid any catastrophic collision in space. And in that regards, this is what we are doing in Europe with our partners. Those 15 member states of the European Union all together, they put their capabilities together, and we deliver a public collision avoidance service open to all spacecraft operators worldwide today since the 1st January of this year. So any spacecraft operator can have access to a public service, including those commercial actors. And it's very important in this endeavor, which is a tremendous effort of those member states in Europe to contribute to the long-term sustainability. It's very important to rely very much on the industry. On top of this, what I call a fundamentally public collision avoidance service, which is necessary to ensure a minimum level of spaceflight safety, there's a need to also rely very much on the commercial industry. And we need them to develop commercial capabilities, SSA capabilities to produce data, SSA data in orbit, and to provide also services, additional services, advanced services on top of those public services to help those spacecraft operators to protect them from risk of collision in orbit. Again, this guideline before is very important because it states that for all of us, we have a common objective to protect all spacecraft in orbit from risk of collisions. And this is a global burden sharing effort. This is what we do in Europe, but I can hear from the different interventions that there are plenty of other initiatives, including from the industry, and this is very positive for us.
Okay, thank you.
Maybe Dan,
yes, please, Andrew.
Just to add to that one, so to extend some of the points that Pascal was mentioning, obviously within the LTS guidelines, capacity building is one of the key tenets of the LTS guidelines themselves. So that's why events such as this are so important, because it's an opportunity for regulators, for those working in agencies, for industry to share sort of the good practice and the approaches that we're using to implement the guidelines, so that when hopefully when emerging space nations join these discussions, essentially they can see what are the practices that have been implemented by those that have operational systems, and how can we then plan our own roadmaps nationally, whether that's looking at the regulatory frameworks or whether that's looking at national technology developments. So I'd only encourage those that are thinking about these challenges around long-term sustainability to join the discussion, to join UN COPUS, to look at some of the work that Dan's doing on the Space Safety Coalition and absorb some of the implementation of these guidelines. So hopefully that helped and extended Pascal's point.
You're muted, Dan.
Thank you. You got me. Thank you for that, Andrew. That did add quite a bit to Pascal's comment. I would like to turn now to Fee and ask, what are GISTA's priorities for implementation of the LTS guidelines within Section B?
So I would like to, Danny, can you hear me? Hello? Okay,
yes,
thank you.
Yes, I can hear you fine.
Yeah. So our plan for the guideline, Section B, this one is, as I informed our colleague earlier, that I separated into three parts. The first part is the policy maker, second part is a regulator level, and the third part is the operator. So in LTS guideline Section B, I believe that there are three parts, such as for the first thing about the policy and the law itself. I said in here that it requires some authority from the state. So in order to do that, so we have to enact the national law to create the structure in order to fulfill the activities that we are going to comply with the LTS guideline. And I believe that for the LTS guideline, mostly it's good for all of the country all around the world to share the information and try to do the SSA and the STA in order to protect our benefit in space. I mean, the sharing of the space is the mutual benefit of everyone. So I believe that the method and the principle of the guideline is pretty good. Moreover, for the operator level, as I informed you guys earlier about some program that we did before, so like Circon, that is the space traffic management software. So we are quite serious to comply with this guideline, and we also do the space weather operation and research in two parts, as I informed you earlier, that it is the observation infrastructure and the space weather forecast system. So now is just the beginning stage of what we did right now, but we hope that in the future we can collaborate with many entities and many companies all around the world in the future. Thank you.
Thank you very much. I saw an interesting question in the chat here. I want to ask Emmanuel about, in terms of this space sustainability rating, have any aspects of the SSR been found to be cost prohibitive, or maybe to some people seen as that, or exclusionary, due to perhaps states' different space capabilities? And if so, what are the recommendations for overcoming that challenge?
So I would say so far the SSR really captures what is the state of the art that is today in terms of space capabilities, and what are the baseline. I would say what is the minimum level required would be like what is the level of the IAD. So if I take as an example is like to deorbit your spacecraft within 25 years. So this is, I don't think today is something which is cost prohibitive, but then of course a best in class actors would be then to deorbit within 5 years or even directly at the end of the life. And this would get you to a higher score, which is slowly also getting to industry standards and today. So in that way, I would say that how the SSR is designed is really to reflect what is done and possible today, but really really also to encourage also best-in-class behaviors and actors that goes above and beyond what is possible nowadays.
Understood. Okay. Let's see. A next question I had. I wanted to see what Amber thought. What might be missing from the current set of LTS guidelines? You were so intimately involved in the negotiations and discussions. So particularly under Section B, safety of space operations, what's missing?
Thanks, Dan. And I'll just say that I appreciate the question, because when we negotiated the guidelines, we were at a cutting edge time. There was a lot of diverse stakeholders involved in that process, and that was fantastic. And there were some guidelines that we got to that were a little more general and broad to allow time for technology and operational best practices to develop through the implementation of the guidelines. And I think that now that a few years have passed, we can truly dive into the implementation of the guidelines and see organically where other areas of work might arise. One area that we've kind of looked at is that could benefit from more discussion is satellite maneuverability, like specifically giving longer natural decay time. Spacecraft operating at higher altitude above 400 kilometers should be able to actively respond to and mitigate collision risk in trackable objects. To account for advancing technology and various potential future solutions, propulsion itself should not necessarily be required for all operators, but they should be capable of operationally responding to conjunction events. A technology-neutral, performance-based standard for maneuverability leaves room for other technology solutions and advanced mission concepts in the future. Policymakers should take into account endurance time on orbit, particularly for high orbit operations, in consideration of the utility of active debris removal. So again, above 400 kilometers of longer decay time, what can we do there to ensure that we can respond to risks of collision? And then in addition, for larger systems of maneuverable spacecraft, it's reasonable for operators to plan to maneuver when the risk of collision with another trackable object in space exceeds 100 and 100,000, an order of magnitude more stringent than current NASA recommendations. To account for changing technology and space domain utilization, the space community should adopt data-driven standards for setting risk response thresholds that are regularly reevaluated to help ensure the long-term sustainability of space. And Dan, I think you've done a lot of work on that, both feeding into the LTS process, but also with the Space Safety Coalition best practices. So thank you for your efforts on that. And then one final thing, I think when we talk about large constellations in particular, talk about orbital tolerance. Operators should be encouraged to efficiently utilize orbital space, generally adhering to the nominal inclination of altitude parameters specified in their license application and grants, closely adhering to specified parameters with the exception of short-term maintenance maneuvers allows other operators to optimally develop and build space systems to minimize radio frequency interference and space safety risks. So those are kind of three areas where I think the committee can do some more work in looking at through implementation, these other areas of common understanding might arise. Thanks, Dan.
Yeah, those are some very good concrete things that should be considered. Next, I'd like to turn to Andrew. Question in the chat was, in the UK license application, operators are asked if they will share data. Some, and perhaps most, I know from personal experience, will be willing to share such data, but it's unclear what the consequences are if an operator were to say no. Can you clarify in the UK license application process for us?
Yeah, no, absolutely, Dan, and thank you very much for the question. So within the UK, our spaceflight regulator is under the CAA, so the Civil Aviation Authority, and essentially they follow our international obligations to authorise and supervise national activities. So this is under Article 6 of the Outer Space Treaty, which calls for any activities of non-governmental entities to be authorised and supervised. So within the authorization process, the CAA have implemented a process by which they have identified key elements that need to be provided by the prospective operator. So looking at the safety of space operations, looking at the sustainability, there's national security elements. So essentially they have a long sort of list of areas that they work through, that they work with the operator to understand the scope of the mission. Within that, obviously, we have areas that we have international obligations, so things like the liability convention. So we require our operators to have insurance for their third-party liability. And then we also have international standards and guidelines of best practice that we essentially require and we expect our operators to implement on our missions. So one of those is around the IADC space debris mitigation guidelines. So the UK Space Agency is one of the 13 space agencies that are part of the IADC, and the IADC itself has a range of space debris mitigation guidelines which look at how missions should look to prevent on-orbit fragmentation. They should limit their presence on orbit and then limit the amount of debris that's generated. So when we're looking at these license applications, we look to ensure how they're implementing these guidelines within the mission. If they don't meet these guidelines, we work with them to try and inform them and help them understand how they're implemented. But ultimately, they're unlikely to be licensed. And then through life, we have activities where we perform continuous supervision. So we have our orbital analysts in the UK who monitor UK registered objects to ensure that they're adhering to the guidelines that they've said they were going to meet in their license application. And interestingly, the IADC mitigation guidelines, and as I said in my opening address, essentially they work through both Section A of the LTS guidelines. So we have guidelines that encourage regulators to incorporate them in their national regulatory frameworks. But then also closer to the operators, it's also shown in B8, where again, it's encouraged that operators incorporate space debris mitigation standards into the design of their space objects and space missions. So hopefully that provides some insight into the UK approach.
Yes, thank you very much. I'd like to turn now to Pascal. Question for you. In your capacity as chairman of the EUSST, European Union Space Surveillance and Tracking, could you explain how EUSST is contributing to the implementation of LTS guidelines on space safety operations? And in your opinion, what's the most important guideline in Section B?
Thank you, Dan, for the question. And I see also another one. Is data from space surveillance and tracking networks shared for free in order to enhance space situation awareness? So I will try to summarize where we are in Europe in this domain. So first, as I said before, probably one of the most important topic in this Section B, in those guidelines, is collision avoidance, because we should avoid, again, any catastrophic collision, such as the one between Iridium 33 and Cosmos 2251. You remember it was in 2009, and it has generated more than 2,000 catalog space debris at that time. So those debris, which have a size over 10 centimeters. So it should not happen again in the future if we have all spacecraft operators have access to a good collision avoidance service. And those data coming from the member states' capabilities, from military sensors or civil sensors, are shared on a daily basis in EUSST, in a database. But we have also commercial data, and those commercial data are not free. We can't share free of charge those data. So we need for those, and this is our role as a public entity, governments, European Union, but public entities could play a role of anchor customer for the acquisition of commercial data to improve space flight safety. And we could play also the role of a public investor to develop those innovative commercial sensors, SSS sensors, to detect space debris in space. What is going to be free is the access to a public service, collision avoidance service, to ensure a minimum level of space flight safety. And then on top of that, it's very important to give the opportunity to the private sector to offer some advanced, more accurate, tailor-made services on top of those public services. Those commercial collision avoidance services would be, of course, not free of charge, but you will still have access to a public free service for collision avoidance, which ensure again a minimum level of spaceflight safety. So those data will not be free of charge, and we need the public sector to play this role of anchor customer and public investor in those commercial capabilities. So I think with that, this is exactly what we are doing in France. I can give you an example. We have a national investment plan, France 2030, it's a huge investment plan of 1.5 billion euros, and an amount is currently spent for acquisition of commercial data and development of commercial SSA capabilities. And in Europe, no later than tomorrow, in Brussels, together with European Commission, I will chair this European Union Industry and Startup Forum on space traffic management in Brussels, with more than 200 participants from the European industry and startups. And we will have this conversation on commercial data provision, development of commercial sensors, and on services, commercial services and public services. So this is where we are right now in Europe. You're still muted, Dan.
Okay, you got me twice. I have a question now for Amber. How do you think we should incentivize the observation and implementation of guidelines by non-state actors?
Thanks, Dan, for the question. I think I saw it on the side as well, so thank you from the audience. Yeah, well, I think it goes back to my my point I made earlier. Really, is like, look, this is a global challenge in terms of sustaining the outer space environment, and it needs a global response, and that includes all stakeholders, to include industry in that process. So everybody needs to come together. I think one unique and great thing about the guidelines developed by the Committee on Peaceful Uses of Outer Space is that during the initial process, they really came up with a way to get the right expertise to the table from all the different stakeholders, to include industry. Did that through kind of the 4 expert groups based on topic for the guidelines. And so I think because industry was involved through that process, and then through their national departments and agencies in the rest of the process, I think for the most part, industry felt included in that process and bought into the process. But I will say this, and this is from kind of an Amazon perspective, but I think industry would come together and have consensus on this. For instance, Amazon is investing billions of dollars into this important mission of providing fast and affordable broadband globally, and really connecting the unconnected. If we invest that money in the environment and outer space, or particularly in LEO, isn't there by the time we are operational, or midway through our operational phase, well, then that investment is kind of gone, right? And so I don't think anybody's more incentivized than industry. I don't think anybody's more incentivized than particularly those operating in LEO to make sure that we get this right, and that we come to the table with best practices that make sense. And so I think really, again, just the partnership between civil authorities and industry and other stakeholders in the process as while building the best practices. And then also part of this conversation, again, thank you, USA and others, for having me as an industry panelist, just being part of this process, which I agree with Andrew is more like of a capacity building discussion here that we're having. So having industry part of this implementation discussion, I think, is really important. Thanks, Dan.
Yes, you bet. Yeah, thank you. Let's see, I'd like to turn to Andrew. I sort of have a double question here, but I'll ask them in part A and B. In your opener, you mentioned that safety of space operations is a theme that appears across all 4 sections of the LTS guidelines. Can you expand on this a bit?
Yeah, no, thanks for that, Dan. Yeah, as you mentioned, so in my opener, I mentioned about safety essentially appearing across the LTS guidelines. Now that's important because safety is also good for long-term sustainability. So the approaches that you adopt to ensure that your operations are safe are also those which will ensure, at least in the majority of cases, that your activities will be sustainable. And essentially that theme continues throughout the LTS guidelines. So in section A, you'll see, sorry, I'm just turning to my, if you haven't got a copy of the LTS guidelines, I don't know if that comes up, but UNOSA have actually published a good booklet. So whenever you're at the Vic in Vienna, do pick up a copy. But in section A, essentially, it mentions about the incorporation of standards and best practice and guidelines into national regulatory practices. So how regulators can look to work those into their national regulatory frameworks to ensure that when we license or when they license national space activities, they're actually adhering to these really good safety principles. It also works through guideline guideline A3 that looks at supervising national activities. So how regulators can ensure that they're in monitoring the activities of their orbital operators to ensure that they're adhering to this best practice. It works in registering space objects with UNOSA to ensure that there's an active catalogue of objects on orbit and that there's the contact details associated with them. And then obviously through B, as we've heard today, there's guidelines which look at sort of the space domain awareness elements. So how should operators perform collision avoidance maneuvers? How should national regulators look to ensure that that these operators are actually following international best practice in terms of thresholds for maneuvers? The guidelines that look at space weather, so we heard from Pascal, so how can you design spacecraft to ensure that they're safe and that if there is a space weather event, that the spacecraft are adequately shielded, but then also on the other side that countries are sharing data on space weather events and that operators know about the events that may be coming. I spoke previously on one of my previous answers about B8, about the design of spacecraft and incorporation of guidelines such as the IADC space mitigation guidelines. But then in C, it talks about capacity building. As I mentioned before, and as Amber mentioned, capacity building and sharing of implementation practices is one of the key elements of the LTS guidelines to ensure that we're sharing these good practices through our involuntary implementation of the guidelines. And then lastly, in D, it's about research. It's about what can we do to look at the environment and to develop techniques to ensure that our operations are safe and sustainable moving forward. So as I mentioned, essentially safety is weaved all the way through the LTS guidelines. And as I mentioned, it's good safe practices on orbit are one of the key drivers towards ensuring that we maintain the space environment.
Yeah, it's a good observation, and here we have these events 1 through 4 for A through D, and the audience really needs to tie them all together. They're not separate; they do complement each other nicely. So thanks for that. I'd like to turn now to Fee to ask your thoughts on what a good mechanism for promoting LTS Guidelines Section B could be. Phi?
Thank you. So I think that the way to promote this is the way when we do the workshop like this. So we can share the information because the guideline itself is already in the website. But when I first read it, some part of it I cannot understand, and I'm sort of curious what is the intention for that. When I attend this workshop and I sort of start to learn from the author what is the importance of it and what is the objective of that. I mean, for the when you guys talk together and clarify many things all together. So I think in order to encourage the people to learn, to understand, and to join this guideline for more and more, is to have some more workshop and to have some other activities all around the world. Actually, I think in by the online is also good, but maybe for the when we have the the meeting at the UN in Vienna, sometime we should have some more workshop in there also. So that's what I think for now. Thank you.
Oh, thank you. I do want to point out, go ahead. Yeah, I do want to point out to everybody that in the chat, Tanya has put the link to these LTS guidelines in all the UN languages. So please grab a copy if you don't have one. It's a good read and it's good content. Now I'd like to turn, Emmanuel, to you. How could actors above space satellite operators use the SSR as a tool to support space sustainability?
Thank you. It's a very good question asking so how actors can use the tool. When you mean actors, do you mean every types of actors or a specific type of actors?
I'd say both. Well, it says above satellite operators, so I would say, yeah, both kinds. State actors and space actors.
So for satellite operators, it's a good way to use the SSR first, also to assess the level of sustainability and to see so how they are doing in terms of best practices and also to communicate on it. With the SSR also, we provide with the assessment a set of recommendations on how to get better. And this is why it's also very interesting because the SSR assessment can be performed throughout the design of a mission. So from early design phase up to the end of life. And we know that all decisions taken the earliest possible will have, I would say, the lowest cost impact on your mission design, but also can also have a best impact after on the on space environment. So this is why it's important also to take on the exercise early on and then to be able to implement those recommendations and also to improve your level.
So Emmanuel, as I'm thinking about the question as it's worded, I think the intent is how could state actors, so the governments and the regulators that are above the satellite operators, how could they use the SSR as a tool to support? I apologize. I understand better now.
That's me. So the state actors, as I mentioned, so in my opening remarks, you can use the SSR as a tool to measure, to see how good the actors are doing, the private actors. And then you can use this to provide financial or economic incentives. So if you're a state actor, you could say, I will provide you tax reductions, maybe if you're doing good in that way. It can also be used as a support for regulations. So in line in the space laws, you can also require actors to have a certain level of SSR. It can be used also to support procurement processes. So state actors and agencies, they procure a lot of missions, and in that way also they can also get a rating also for their missions. First, to show that the missions that they procure, they are sustainable, but also as a tool also to understand what is the how the different actors are doing, and also in order to get this recommendation exercise and also to get better. It also can be used for the public, also to communicate to the public, because it's very complicated today for citizens to understand how space activities are doing in terms of sustainability. The public is much more concerned about the climate change with the global crisis, and they are questioning also governments on how they are doing, how they are procuring. So this is also a good way to communicate with the citizens, and also in general, also to communicate exactly for those aspects. So that would be a few ways how state actors can use the SSR in terms of sustainability.
Very good, thank you. Next question, we have 5 minutes left, so maybe we can fit in one last question here. Is to Andrew. It's in the chat. Could you elaborate a bit on how the UK monitors daily compliance and deviations if they're found to the granted licenses?
Yeah, no, thanks, Dan. So yes, as I mentioned, within the UK, our spaceflight regulators within the CAA, so they're responsible for licensing both launch and orbital activities. Obviously, the supervision role is different between the launch activities and the orbital activities. So they have a certain type of things that they monitor and throughout the life of the license. So specifically looking at the orbital activities, so within the UK, we have a network of SST capabilities, so space surveillance and tracking capabilities. And within the agency, we have access to those through our orbital analysts. So our orbital analysts will monitor the UK license objects. And as I mentioned, there's a list of those that can be found on the gov.uk website. And regularly they'll monitor where those objects are and whether they are adhering to the mission profile that was initially agreed within the license terms, or whether there's an anomaly and things. Also then during the life of the license will also be engagements between the operator and the regulator to discuss the health of the spacecraft. So obviously through the telemetry, we have the operator will have access to health data on the spacecraft from monitoring the pressure within the propellant tanks and other telemetry key health performance elements. And so through the life of those activities, obviously then the regulator will be able to supervise how the spacecraft is functioning, both directly and indirectly, essentially. An interesting point is then moving forward. So as we get to more complicated missions, as missions are performing close proximity missions, how that supervision role evolves essentially, and that's something in the UK we're actively considering now. So hopefully that answers the question. Thanks, Dan.
It does, yes. Thank you. Well, that brings us to the end of our time. I would like to give the panelists an opportunity to put in any last words, if you'd like. I'll start with, well, Andrew, since you just went, I'll start with you.
Thanks, Dan. So ultimately, and I think I mentioned it a few times within some of the remarks I made and some of the answers to the questions, forums such as this are extremely important to sharing how we all implement voluntarily implement the long-term sustainability guidelines, because it's the approach by which we really share good practice and we sort of converge on how we're implementing these. So I really just encourage those who are interested in the long-term sustainability guidelines, whether you're a regulator, an agency, an operator, to really engage in the discussion and look for the useful outputs such as these events that so regularly publish. So thanks, Dan. Thank
you very much. Pascal?
Yes, thank you very much, Dan. So first, I would like to thank again UNOSA for organizing this awareness raising and capacity building session on section B of the implementation of space safety operations guidelines. Really, so this is very important. So my first message to the member states is again, it is our collective interest to timely implement those LTS guidelines in order really to contribute to the long-term sustainability of our outer space activities. Those guidelines are important in that regard. And maybe to the private sector, I cannot agree more with Andrew and Amber, and I'm very happy that Amber, representing today the private industry, the private sector, is part of this conversation, because the private sector should join this multilateral LTS process. They are part of the conversation because most of the assets up there are commercial satellites, much more than government satellites. So, and this private sector also drive the innovation for the next years. So it's very important that they implement in their solution the answers to the challenges ahead of us of long-term sustainability of outer space activities.
Okay, thank you. And let's go to Phoenix.
Yeah. So thank you. So thank you very much for UNUSA for give the opportunity for me and my organization to share some information that what we do, and we will do in Thailand right here. So I learned a lot from everyone. So thank you very much, especially in the meeting chat box. So there are lots of questions in here, which is very interesting question, and some question give me a lot of knowledge and something that I have to learn and have to do in the future. So thank you very much.
Yeah, thank you. Emmanuel?
So thank you very much also for having me a part of the discussion. So my main takeout is, so the long-term sustainability guidelines are, I would say, complex also to navigate. You really need to be an expert, and even myself, I learned a lot today. So thanks also for all the views from the different actors. So discussion is very important. We all have in mind the same goal, the long-term sustainability of outer space. I think with SSR, we really allow to have a framework, a methodology to assess and communicate in an easy way also those aspects, and that also can help to pave the way into capacity building to different type of actors which are not especially space experts. So I would say this is I think important to mention. So thanks a lot for having us here.
Thank you. And then let's turn to Amber next.
Thanks, Dan. Just Pascal and Andrew took the words out of my mouth. So I will be fast and just say thank you for the opportunity. Once again, thank you for the audience for the very thoughtful questions. And that is it. Thanks, Dan, so much. I really appreciate it.
Yes, and I want to echo some of the sentiments from the chat as well. Thank you to all our panelists and your sharing of your expertise. Our thanks to UNUSA for assembling this. As we could see today, LTS Guidelines Section B has much important content. It is, in my view, the heart of implementation of space safety. So it's a great document. But there are later sections, C and D. So there are equivalent events to this one coming up. And I believe it's the 12th and the 26th of June. So please schedule that up on your calendar to attend, and we can learn more about the other sections of this document. Thank you very much.
Thank you very much. Thank you for that.
Thank you very much. Bye-bye.